Compare and contrast the Hubble Space Telescope and the Next Generation Space Telescope.
Hey guys, Van and I are with Dr. Eric Smith. He's an astronomer at NASA Goddard.
So, Dr. Smith, what is a Next Generation Space Telescope?
Well, the NGST, or Next Generation Space Telescope, is the logical successor to the Hubble Space Telescope, or HST. NGST is designed to see the first stars and galaxies that light up in the universe. To do this, we need to work in the infrared part of the spectrum. So that's one very important difference. Another important difference is just how the telescope looks. HST looks like a very familiar telescope to most people. It's a tube, it's got a mirror at one end of it. NGST, because it is so large, 4 times the size of HST, is going to have to be cut up and folded in a rocket, and then it will be launched into space, and it will sort of bloom like a flower, and then it will have a sunshade to block light from the sun and protect its optics. That sunshade is about the size of a tennis court.
It's huge.
It is.
Yeah. Now, one of the other important differences between HST and NGST is where it will be. HST is about 200 miles above our heads orbiting the Earth. NGST will be about 1.5 million kilometers from the Earth, farther than the Moon. It's being put there so that it can be in a very cold environment, which again is good for telescopes that have to work in the infrared. It also means that no one will service the NGST.
How do astronomers like you use algebra when you're designing or dealing with the NGST?
Well, algebra is used at all stages in the design and construction of a telescope. Astronomers used algebra at the very beginning when they decided how they wanted to optimize it. I mentioned you wanted to optimize for the infrared. Well, you can use algebra to tell exactly where you want to optimize this telescope to work. And you do that by studying galaxies and knowing where they emit their radiation.
Now you said that the NGST has a sun shield that's the size of a tennis court?
Right, and the reason it has a sun shield is to protect the telescope optics from getting sunlight on them.
Wow, okay, now, so are you guys working here at NASA Goddard on the sun shield?
A little bit, but a lot of work on the materials are being done at NASA Langley.
Hey, that's where we're from. Why don't we head down to Hampton, Virginia and meet John Connell and find out more about the sun shield?
Here at the NASA Langley Research Center, we're working on a number of technologies that are relevant to the Next Generation Space Telescope. The sun shield is comprised primarily of polymeric films. Polymer is a term that means many repeat units of the same structure. Common examples of polymers that you would encounter in everyday life would include things such as saran wrap, food packaging material, milk jugs, compact discs, things of this nature. The materials we are developing are primarily for the outermost shield of the Next Generation Space Telescope. As you recall, this shield is designed to keep the optics as cold as possible, so the shield has to be very reflective. The outermost layer in particular has to be very reflective and be resistant to the radiation environment. As you can see, the material looks much like the Mylar balloon that you might encounter at a birthday party or other type of event. The chemistry of them is such that they are much different and they will be resistant to the radiation present in space. Polymer chemists use algebra in their everyday working activities and the calculation of the recipes necessary to make these advanced polymers.
Well, that about wraps up this episode of NASA Connect. It was a blast, wasn't it, Van?
Oh yeah, it sure was. Jennifer and I would like to thank everyone who helped contribute to this episode.
We sure would, and you know, Van and I would love to hear from you with your comments, your questions, your suggestions, or ideas. So just write us at NASA Connect, NASA Langley Research Center, Mail Stop 400, Hampton, Virginia 23681. Or you know, you can find us on the web at connect@edu.larc.nasa.gov. Hey teachers, if you would like a videotape copy of this NASA Connect show and the Teacher's Guide, contact CORE, the NASA Central Operation of Resources for Educators, or check out this website to locate your local NASA Educator Resource Center. All this information and more is located on the NASA Connect website. For the NASA Connect series, I'm Jennifer Pulley.
And I'm Van Hughes.
See you next time. Bye.
Bye-bye.
It was fun.